Hello everyone. I'm going to show you the AI components in current VK system. And so when we talk about recommendation or personalization, we encounter this kind of recommender system in our daily life. For example, if you use Spotify or Netflix, basically they have your user profile and they have also your browsing history. So this kind of information can build a context for further recommendations. So they can recommend what you may interest. So that's the basic idea of context-aware recommendation. And in our WeCare system, we have also the similar concept. Basically, we have a smart agent. We have also patient. Well, the smart agent is the recommender system, and we get the information from the patient. At the beginning, the smart agent has not so much knowledge about the patient, and he observes some context, and he chooses an action to recommend to the patient, and he receives, with the interaction with patient, he receives a reward. And so he observes another context and choose another action and receive another reward. So iterative, he does this in many times so that he has more and more information about the patient. And so he can map this kind of context information and with the actions to recommend to the patient. So that's the basic idea of our contextual bandit concept in recommendation. So the workflow is that every day morning at 8 a.m., we push a notification to the patient and telling him how many steps he needs to achieve. And when the patient goes to the avatar app, he taps the health information and we will show him that what he has already achieved and what is his daily goal. So when the synchronization works, and here we can see first a visualization of one patient about 1 month data we have collected from the system, which has 30 data points. And you can see you cannot see much how the blue one is the recommended steps and the origin one is the achieved steps. But I don't think you can see much how well the recommended system has worked. So because we have only 30 data points, it's quite few, and we have done another simulation with about 1 year data from a real person, and we have used our recommender system to recommend to and do this kind of simulation, use information like what's the weather, what's the mood of the person, and also what's the historic steps of the person. So basically you can see that for this person, we have a minimum threshold of 4,000, which means the maximum threshold is 8,000. So you can see basically our recommended step, the blue line can capture the trend of the daily number of steps quite well. And then we come to our second use case about e-learning recommendation. In e-learning in different apps, we have different categories of e-learning. For example, for the stroke case, we have 6 categories. And at the same time, we have different patient profiles from professional portal, which describes basically in a different level of disease of the patient. So we use this kind of context information to recommend the right videos for the patient. And then reward function is built from a liking assessment, which means that at the end of the video, the patient would give a direct feedback how he likes the video. And second reward is that if we say that if the patient has finished watching the whole video, we give 5 extra bonus to the reward function. So here you can see our result in pilot phase. Basically, we can see 6 different categories of the e-learning, and you can see how many times we have recommended in total to a patient, and you can also see the reward. Basically, you can see the reward is somehow very close yes, create some problem for us, because which means that the patient has somehow the same preference for each category, which means all these categories are relevant to the patient. So somehow is this recommendation quite randomly, but still we can see that the patient were quite happy with this recommendation. Basically, from the feedback from the reward function, we can see that these are quite high. And now we have finished our demo of 2 use cases, and we have further try to search some potentials for the AI components in the future for VK project. The first one would be some basic one is about the sensor and the telemetry app data. Currently in the system, the amount is relatively low, so our smart agent cannot utilize all this kind of data. And also somehow the data quality may not be so high, so we need to include further, for example, ordinary detection functions to detect some abnormal data points in a telemetry app or in a sensor data. And I think we also need to extract more context information from the sensors which are installed at patient's home. This is the basic one. And we have also explored more advanced options. For example, currently we have a pathway system which is modeled with BPM system, which is quite deterministic. And we have explored further possibility with our conics in 2D, and we found that the goal-oriented model might provide more possibilities and flexibilities. So the basic idea, so from us, the basic idea is at the beginning, we can use the deterministic pathways, which we can use to collect more data from patient, and then in advanced level, we can provide more with goal-oriented modeling with more personalization and recommendation. So yeah, so we come to our conclusion slides. Today we have introduced the context-aware recommendation concept, and we have 2 use case demos. And for further in the project for the outlook, we think that goal-oriented modeling may provide more flexibilities and for personalization. And last factor is about the factors we have in the system development. We found that is quite important. The first one would be that we need to define the use case and the use scenario. The second one would be the legal and ethical issues, how to collect the data and whether the patient approval. We have an approval from patient. The third one would be the proper amount of data for the models we have chosen. And the last one is all quite important. We need, before we hand the product to the patient, iterative test, feedback, and improvement. So continuous development is quite important. Yes, that's all from our side.